Hi, Joris, and welcome everyone to this Ask Me Anything session with Trifork CTO, Joris Kuipers. So I'm Vika, and I'll be today's AMA host. I am part of the GOTO Amsterdam team, and we have a lot of online events planned for you in the upcoming months. So you can, of course, follow us on Twitter and LinkedIn at goto.com to stay up to date. So about today's session, first Joel will shortly introduce the topic of Spring in a cloud-native world, and then we'll move forward to answering all the burning questions. I will first read all the pre-submitted questions that are also included in the description box, and then Joris will answer all the remaining questions from the chat. And now let's welcome again Trifork CTO Joris Kuipers. So could you maybe tell us a bit more about your experience and topic you specialized in, and elaborate a bit more about different Java versions?
Yeah, sure. Thanks for the intro. My name is Joris Kuipers. I work as a CTO and hands-on architect at Trifork Amsterdam, which is one of the many offices that Trifork has worldwide. We do a lot of custom software development that uses Java and Spring. Nowadays, also Kotlin and Spring. And I have quite a strong background in doing Spring-based development because I used to work for the company behind the Spring framework, which started out as Interface 21, then became SpringSource, then became acquired by VMware, then spun off into Pivotal, and now is back at VMware, actually. So that's quite a journey. I left after the VMware acquisition to join the current company. And as such, I'm still involved with setting up systems and developing systems using the Spring Stack, as well as a lot of other open source technologies. We are very much focused on open source. And a couple of years ago, as Rika said, we also became a training partner for what was then still Pivotal. So we also deliver the core Spring training regularly, and next week is another edition of that one. One of the questions was on the version of Java that people were using. Yeah, so that's interesting. I'm seeing a lot of different usages still of Java, especially in enterprise. Traditionally, people are lagging behind a bit, and sometimes a bit more than a bit, especially companies that are on the, let's say, old school Java EE application servers. Very often are stuck still on Java 8 or lower. When it comes to Spring, you're probably aware, but I'll mention it anyways, that even with the latest Spring version, Java 8 is still the minimum baseline. So that means that everything that is actively being developed on newest versions will actually still work on Java 8. However, Java 11 is currently the long-term support version of Java that most people use, I think. That's also what I see here in the poll as it's changing. Java 11 is also a version that we are very actively using in a lot of our projects. We're using a mix of OpenJDK as well as also the OpenJ9 virtual machine from Eclipse. If you haven't heard of that, I would definitely consider checking it out. It's an alternative to the OpenJDK virtual machine, and it has a number of features, but one of the more attractive ones is that the memory usage of the OpenJ9 tends to be a lot lower than the default OpenJDK one. And that's the reason that we're actually using it. We're doing a lot of projects where we have a whole fleet of microservices running, and you can simply fit more services onto a server if they don't consume that much memory. Actually, for the start of next year, for my own personal projects, I'm considering to do the upgrade to Java 15. As you may know, there is no newer LTS, long-term support version beyond Java 11 yet. So even though you may think that it's every 3 versions, Java 14 is not, in fact, a long-term support version. However, the latest versions of frameworks like Spring have been fully updated to support Java 15. Java 15 itself has a lot of interesting features. Some of them were just further developed features that were introduced in Java 14, things like records, for example. Even though it's not an LTS version, there are already point releases, both of OpenJDK as well as the OpenJ9 that I just mentioned, which I think means that it's stable enough. And of course, if that means that it's stable enough for you as well, depends on the situation. But we at Trifork, Even though we don't want to have bleeding edge, we sure do try to stay on current versions and and make use of new features and technologies. So that's something that we are actually trying. Right. Good thing, like I said, about Spring is that even if you're on 8, you're still okay. But if you want to go all the way up to 15, you're actively supported there as well. So let's leave it at that for the Java version, and let's move on to another question.
Now let's move to the pre-submitted questions. So I will start with the first one. One of my providers, I am calling his service via HTTP, requires me to change password. Password is sent with each request every month by calling a dedicated change password endpoint. Currently, passwords, a single one per env, are stored in properties file. So the question is, if I execute his change password, how can I easily update password in properties file and even push it to go?
Yeah, so to just summarize, basically what the problem that the people, the person asking the question has is, we have something that is considered to be a configuration property, in this case a password, but it changes over time. It changes every month, in this case as a result of an HTTP request. Well, we are used to storing these things in property files. So what do we do? Do we update the properties file? I would go back a step and say, well, that's the wrong question. The question shouldn't be, how do I update my properties file that I use to initialize my configuration? The real question should be, where do I put this configuration? And my answer wouldn't be try to update your local properties file, because typically properties that you package up with a Spring application or that you put next to an application, they are considered to be quite static, and certainly not something that you would want to update on a regular basis automatically. Good news is that for Spring applications, the idea of configuration is something that is a built-in abstraction. So Spring has something that it calls property sources, and the property source could be a properties file, as the person asking the question is already using. But properties could also be an environment variable. They can be a system property, or they can be actually something like a remote system where you get your configuration from. And that's actually what I would do. Before the latest release of Spring and Spring Boot, this meant that you would need to use something called Spring Cloud, which has support for external property sources. So you could store it in a database, or you could store it in some other service, and then during startup, you could just retrieve the password from there. Actually, in the latest release, they made a change so that now with the latest Spring Boot 2.4, Spring Boot itself actually has support for externalized property sources. So that's one of the things I'm going to change in my own applications. We are currently using the AWS parameter store for storing configuration, including secrets and passwords. And that becomes active as a property source in the application. This is something that I would probably write as a custom implementation of exactly that mechanism. And then you can just use any persistence mechanism for storing the password. It could be a database, which would be kind of an obvious solution. Or if maybe retrieving the password is something that you could do on every startup, you could just keep it in memory and make that into something that you do during the bootstrap of your application. The nice thing about solutions like this is that after getting this in place, and for the rest of the application, the code doesn't need to know or need to care if this password came out of a properties file, or if it came out of some variable, or if it came out of an external system. It's all just going to be another property that's available for resolving in your application, which means that for local testing, for example, you could also still put it in a properties file that you read from there, and you don't need access to the same system that you need in a production setting. So that's what my solution would be. I would not try to update a local properties file. I would just try to store the password somewhere else, but still treat it as another property source.
Okay, thank you so much. So now let's move to another question. The question from Yogesh. I really hope I pronounced the name correctly. If not, I'm so sorry. So the question would be, reactive applications seems to be in thing. Given this is such a paradigm shift, what should be the considerations when deciding to implement or not to implement an application using reactive framework? For simplicity's sake, assume a greenfield application with no constraints using a reactive complaint database.
Yeah. Yeah, so the question is basically, when would you want to use the new reactive support? So in Spring, that means stuff like Webflux, Project Reactor, R2DBC. And it's a great question, because it's a question that we ask ourselves a lot when we start new projects as well. The reactive support in Spring has been out now for about 3 years. But 3 years ago, when we started projects, we still considered it to be too new of a thing to already immediately incorporate into bigger projects. Because one of the things that's definitely important when you consider to go reactive is the whole stack, start to end, top to bottom, needs to be able to support a reactive model. So, for example, the database used to be an issue there. There were very few reactive database drivers, especially in the relational database world, 3 years ago. So for us, that was actually a consideration for many applications to stay on the traditional thread per request servlet-based approach. This has changed, however. So nowadays there is R2DBC support for relational databases. Also, the frameworks building on top of Spring, things like Spring Security, now have excellent support for doing reactive. So what I see is that a lot of the technical limitations that used to be a reason not to choose reactive have gone away. So then the next question becomes, okay, so if there is no objection to doing reactive, then what are the pros, right? Why would you want to choose reactive over what's probably a more familiar program model? And what we're seeing there is that the main driver there is just more efficient use of resources when you have a lot of parallel incoming requests that you need to handle. That's really the main use case for doing reactive, because reactive is just a lot more effective in dealing with these things. Having basically a thread per CPU core and an event loop model is a lot more effective at dealing with lots of parallel connections that you need to have open, web connections typically, compared to the traditional servlet-based model. So we have a couple of applications nowadays that are built on the reactive stack. And we're seeing really nice results there when it comes to resource usage. But it's not necessarily our default go-to model. If I would build, let's say, a simple application that is used internally by a handful of people within a company to manage some database, and I just need some quick views on that, I would probably not consider to do it with a reactive stack. Because I know that not just for me, but also for a lot of the people that I need to work with and that you need to understand the architectures that I'm setting up, it will just be simpler to use a more traditional model. Every open source library will probably integrate with it. Everything that is based on things like thread locals, for example, will work out of the box. So if you want to go for a reactive, I would say that the main driver should be that you know you're going to be having a lot of concurrent requests that you need to handle efficiently. So instead of needing to horizontally scale a whole bunch of different instances, you just want to have a small number of instances to handle the same load, which will just be cheap. And then you need to check for the entire stack. Okay, is everything that I want to use, is that already supporting this program model? And the good news is that nowadays that's more and more the case. Certainly within the Spring ecosystem itself, I think they're fairly complete nowadays when it comes to having reactive support in all of the actively maintained frameworks. But I see it in other areas as well. Of course, you do also need to realize that you won't be able to deploy to, let's say, the traditional Java EE application servers that are still running WebSphere on IBM Java 8 or something like that. So that's also a consideration, right? What is your actual runtime environment? But if you're doing things that we're doing, basically just putting everything in a container and then running that on Kubernetes or some other managed platform, then that should be absolutely fine. So those are the main considerations for us when we decide between doing a reactive or a traditional stack. And we currently have a mix of both. I also don't really see reactive becoming like the dominant model anytime soon, to be honest, because I think the program model is quite complex. There's still some issues around debugging. There's still some issues around stack traces, that sort of thing. Those issues are being dealt with, and there are tools that will help you with this. There's Blockhound to see if there's any blocking code in your code, that sort of thing. But it's definitely not as mature yet as the whole tool chain for the traditional model. So keep that in mind.
Okay, I see Sam follow up. It's not necessarily a question, but Jakub said
Regarding configuration question, even when you store configuration setting, let's say password in DB, how would you propagate changes of this password to all instances in
I would
DB?
assume if you have a database, that the database is actually shared across different instances of your application. So you would put it in a shared store, right? I'm going to assume that you don't have a dedicated database instance per instance of your service for this model. And database, right, could be a relational database. It could also be something like a Redis or anything else that allows you to hang on to the data and make sure that it's stored centrally.
Okay, and then we actually have another question from Jakub. So
yeah, so the question is about, okay, but do I need to then actively get the configuration from the database for every request? And the answer is no. The whole idea behind the abstraction I was mentioning, that you get a property source, is basically it's only created once at startup. And if you need to, there is support to refresh certain configuration values if you know that they change, but then you would only do it on demand. So instead of having a polling model where you have to check all the time if something changed, you would build in a mechanism so your application actually gets a trigger to know that, hey, my configuration changed. I need to update everything that uses that configuration. So for things like logging configuration, that's actually built into Spring. For other things, you can use an @refresh scope annotation on certain beans that you want to actively refresh if your configuration changes. Could also be that it's actually an easier option in your case to simply restart some services when you know that it's just going to be once a month at fixed times that these things change. That depends on the use case and how quickly you need the change to propagate amongst your instances.
well, I hope that answers your question, Jakub. And if anyone else has some follow-up questions, just shoot them in the chat. And now we have one more pre-submitted question that I'll read. So, cloud-native applications ideally should have quick startup time and low memory footprint. This is especially important in the dynamic world of Kubernetes and fast, where pods functions are spun up multiple times a day. Though we do see many Spring applications being deployed in cloud, this feels like squaring the circle, especially given the image size, more than 400 megabytes, and non-trivial startup time. Due to heavy use of annotation processing and reflection during startup of a moderately sized Spring application. So the question is, would Spring, or for that matter, Java, still be your first choice to develop a cloud-native application from scratch?
Yeah, so that's the real question. And the short answer is it depends, because I don't think every cloud-native application is the same and has the same requirements. For example, even if you are running on Kubernetes, which we are as well, and also other Docker orchestrators, that doesn't mean that new instances of your Java services will be spun up like every minute. Right, that's not how it works. If you have a service that's happily running on a pod, and there is no need for scaling up or scaling down, then by default Kubernetes will just keep the thing running. So in those cases, startup time is not actually all that critical. You don't really gain much, I think, by shaving off a couple of seconds of the startup time of the service. You do need to take into account that indeed it might take a little bit longer for a full-blown Java Spring Boot application to start up than it might for other types of applications. So things like how quickly should the application respond to health checks and that sort of thing is something to take into consideration there. I don't really consider it a problem otherwise. Memory usage, though, is a different concern. And this is one of the reasons I mentioned that we are using things like the J9 virtual machine, because it shaves easily like something like 100 megabytes of at runtime of every instance that we have running. So if you add that up, it adds up rather quickly. The main problem that I see with Java for cloud native is if you want to use it for serverless development, because in those cases, you don't have services that just start up and are long-lived, even though you might get a bit of scaling up and down every now and then. You actually get instances that do need to be started and restarted all the time. I would say that the traditional model of using Java, especially with, as the question says, relatively heavy technology that Spring uses, like lots of reflection and lots of class loading at startup time, which has a real overhead, is certainly not the best way to do it. There's two options there. Obviously, you can use something else in Java. So a lot of people are doing things like serverless with JavaScript and Node, for example. However, what I think is a super interesting development is what is happening in the GraalVM space. So GraalVM is a technology that's being developed by Oracle, and it's actually a bunch of things. But in this context, what is relevant for GraalVM is that it can take a Java application and it can compile it into native code. And that solves both issues that were mentioned in the question. First of all, it solves the startup time because it's going to be milliseconds rather than seconds, so super fast. But also the runtime overhead in terms especially of memory usage is reduced a lot. Right? Your application is not actually going to be faster at runtime, but it will consume way less memory. Right now, 2020, you can already sort of do this with Spring Boot. But support is limited. So this is something that is actively being worked on. The Spring team is also in close contact with Oracle to make sure that new applications will actually properly compile and run using GraalVM. But there are other options there as well. I think the two most well-known are Micronaut. Micronaut is interesting because the programming model is actually very similar to that of Spring. That's not by accident. It's built by the people who used to work on Grails. But Graham Rocher, the lead for that, has recently this year has been hired actually by Oracle directly to work on Micronaut. So that means it's actually backed by Oracle. And even though not many people may like Oracle as a company to do business with, I think it's quite reassuring that the same company that is actually funding Java is also now funding the development of that framework. It means that they're in it for the long run. This is not just going to go away. And then there's Red Hat with their framework Quarkus. Which also has been built from the ground up to support compilation to GraalVM. So those are certainly things you could already start using right now today. And I think next year that we will see some important big steps being made in the Spring ecosystem as well, so that Spring can actually follow suit and will also be more suitable than it is right now, even to be compiled down into native code using GraalVM. So that's for serverless, that's interesting. But even if you're not doing serverless, the reduced memory overhead, I think, is still worth doing that. So so the question is, I think Java's catching up, or the answer really. You can use Java for a lot of cloud native development already. We're doing it, but a lot of people in the world are actually doing it. But there are some obvious downsides compared to alternatives. But I think those are temporary. And I think that 2021 will actually be the year where we will see Java becoming like a first-class citizen again for this sort of cloud-native development.
Well, thank you so much, Joris. So now we will fully move to the questions from the chat. We will have to wait for a second, but yeah, maybe in the meantime, you could tell us some, I don't know, best tips or something more about your Java practices.
Yeah, or I can tell a little bit about what I'm currently working on myself. So for a while already, we are working on a big integration platform that we are developing for the Dutch loaders. So that means that we are building lots of web services using REST APIs. And we are exposing a lot of different backend systems, most of which are also exposing REST APIs. We are running this on AWS. So we're using their Docker orchestration platform, currently ECS. We are migrating to EKS. And we are using some other services that they provide. So a lot of what we do is based on Spring Boot, Spring MVC, REST templates still, not the web clients, because when we started the project, it was just a little bit too early for already moving into the reactive days. But we are fully up to date. So recently I updated to the latest Spring Boot 2.4. So if you haven't seen that yet, that came out just a couple of weeks ago. And actually, today they announced already a bunch of minor updates to the latest Spring Core frameworks. And Spring Boot is expected to follow along somewhere next week, I think, or maybe the week after. So this year we will see a 2.4.1 release of that one. One of the things to consider there is, like us, if you are combining Spring Boot with Spring Cloud, Spring Cloud is currently not yet compatible with the latest Spring Boot version. We are using parts of Spring Cloud, but not that many. So we hit a single incompatibility. And for now, I've actually worked around that one myself, because I could just shadow a class from Spring Cloud and remove a method there, and everything works. But it's not necessarily something I would recommend everyone to do, because you need to be very much aware of the internals of the framework in order to do that. New version of Spring Cloud is also planned to come out, and actually the milestones are already there. One thing to consider there, if you are on Spring Cloud, is that all of the stuff that is based on the old Netflix stack, supporting Hystrix, supporting Zool, supporting Ribbon, is actually going to be taken out of the standard release, starting with the next major release train from Spring Cloud, because it has been deprecated. It has been deprecated for a while. They have announced this quite a while already, and alternatives have now been made available. So that's also something that I'm planning for next year. Right now, I'm just working with latest Spring Boot and a workaround for the old Spring Cloud. But something that we will address in the first quarter of next year is that I'm actually going to rewrite parts of my application to replace the outdated Netflix stack with some of the new alternatives that have been developed over the last 2 years or so within the Spring Cloud umbrella. So for things like circuit breaking, instead of Hystrix, there's now an abstraction called Spring Cloud Circuit Breaker, which supports things like Resilience for J and a couple of other solutions. For Ribbon, we can actually just take it out because we don't really need it anymore. But basically what it does is client-side load balancing. There's a new client-side load balancer abstraction as well. And what Zool is doing, something that we are also using, is it's a proxy. And there are many solutions for providing proxies, including Spring Cloud Gateway if you need a standalone proxy. But yeah, that's some development in that space that's happening that you need to be aware of if you want to upgrade to the latest versions.
Okay. Yeah, great. Thank you so much. I think that should be helpful. So if there's any follow-up questions, or if you have, any questions in different topics, something about Spring-based services, Java, or microservices, feel free to ask us.
Yep, I'm happy to just keep talking, so let's do that. So there were a couple of questions about reactive before. So as I mentioned, we have been using reactive in some of our projects. First one, we just used Java with the Spring Reactive support. So that's using Webflux and some of the other parts based on Reactor Core, but still with Java. Right now, we are actually working on a new project where we are combining this with Kotlin. And I'm not working on that myself. One of my colleagues who is an architect is driving that project. But what I think that's very interesting there is that the integration that they have there is that they can use Kotlin coroutines. So if you haven't worked with Kotlin yet, Kotlin is another JVM-based language from JetBrains, the creators of IntelliJ. It's been in development for quite some time already. It targets both standard, let's say, backend systems as well as Android. So you can use it for native client-side development as well. But what's interesting about Kotlin is it's not just a little bit of syntactic sugar over Java. They actually have some quite unique functionality. And part of that is coroutines. And coroutines is a way that allows you to write code that is inherently reactive, but you can write it in a much more procedural fashion. So if you have ever looked at the reactive support in Spring proper now, then you're probably aware that they are using another project called Project Reactor, which is also maintained by VMware. And that uses monos and flux everywhere, basically, to represent data that will become available after executing a reactive pipeline, where a mono is a single result and a stream of result is called a flux. Now, you can work with this, and it works quite well, but it's something that is very invasive. It ends up everywhere in your APIs and in your application. It's not a concern that is actually hidden from you. It's very much in your face. Some people like that because it allows you to easily compose functions out of fluxes, for example. But it can also be quite tricky to wrap your head around, especially when you also need to think about, okay, so where do I have thread boundaries, and if I need some buffering, where actually does that sit? It's also super hard to debug and to troubleshoot if you make a mistake in there. With Kotlin, they support something called a coroutine, where basically the language tries to help you with doing things in a reactive fashion. So at runtime, you will still be working with things that are essentially completable futures or streams, things that still need to be processing something in order to come up with a result. But in the programming model, it looks much more like the traditional imperative model, where you simply have a function that returns something. The keyword that they have for this in Kotlin is suspend. So you're going to have a suspend fun, which is a suspending function. It's not something that tells you that you need to suspend having fun. But yeah, I think this is one of the super interesting developments for now, at least, in getting the best of both worlds, in the sense that you do get all of the benefits of reactive that we talked about before, but not necessarily all of the downsides that I think are there in terms of the complexity that you end up with in the program model. For next year, hopefully, we will see something coming out, something that you can actually start to use in enterprise Java applications already, out of Project Loom, that is currently being developed at Oracle. And Project Loom is yet another way to deal with concurrency models, where basically they are implementing a lightweight threading model. So instead of having operating system managed threads as your Java threads, which is the traditional way of working, you're going to end up with a program model that's super similar. So you can still pretend that your code is running in isolation on a single thread, but those threads will be much more lightweight, comparable to what you see with frameworks that support an actor pattern, for example. And it will be very interesting, I think, to see if how frameworks can adapt to that and how easy it will be to write enterprise application with that. Because this might actually be the thing that becomes more mainstream, I think, than just doing the current reactive way of developing applications.
Yeah, we received a question through the forum now. So the question is, haven't used current Spring version much in the past 2 years, but I do have a question. What is the Spring's answer to new frameworks like Micronaut and Quarkus that make Java services more case-friendly?
Yeah, so I talked a little bit about this already, but I can expand a little bit. So I think both Micronaut and Quarkus have been super interesting to follow, and also have been a real driver to get some innovation in Spring, because basically they were forced to catch up with these frameworks that were built to be more, let's say, cloud native ready from the ground up. There's a couple of things there. If you look at frameworks like Micronaut, then one of the things that they do is they try to reduce the use of reflection. And that helps with starting up very quickly. And it also helps, by the way, with reducing memory, because frameworks like Spring need to cache a lot of metadata about classes in order to work efficiently with reflection. And that adds up into memory count. There's a lot of stuff actually that's happening in Spring that has been driven by the competition of these frameworks. So already more than a year ago, they did a lot of investigation in performance and overhead to measure where can we improve on this, and a lot of those improvements have already found their way into the current versions of Spring Boot and the core Spring framework. Like I said, another interesting aspect about Micronaut and Quarkus is that they also try to make it easy to compile your applications with GraalVM to native code. So that's something that is also actively being worked on for Spring. It's harder for Spring because, well, they are a framework that has already been out there for 15 years, heavily relying on things that don't necessarily work well with GraalVM. But it's definitely getting there. So they need to catch up, but I do see that happening. But if it specifically also comes to being Kubernetes friendly, there is already a ton of support in there. So if you look at current Spring Boot versions, out of the box, you don't even have to configure anything for that. If the application finds out at runtime that it's running inside of a Kubernetes pod, it will automatically offer liveness and readiness endpoints, actuator endpoints, so that Kubernetes can see if your application is running. There is currently support to make sure that if your application shuts down, that it does a graceful shutdown. So it first stops accepting incoming requests, but it will continue to process the in-flight requests. So this is perfect for schedulers like Kubernetes or ECS or other orchestrators, where stuff gets being brought down and being back up all the time. There is a lot of support nowadays for working with Kubernetes in terms of configuration. So yeah, that's definitely there. Then there is another question about the Micronaut community. Does it compete? Yeah, a bit, for sure. And I think it's very healthy competition. Like I said, the Micronaut framework was developed by the people behind the Grails framework, including the lead developer there, Ray Rozier. And their idea about APIs and how to make a developer-friendly framework are actually super similar to the philosophy that you see in Spring. So there is no real competition there. I think they want the same things. And if you, as a Spring developer, if you have a look at Micronaut, you feel right at home, right? They use annotations that are similar. The program model is similar. But under the hood, it's very different. Because, like I said, it tries to just refrain from using reflection. It does everything at compile time. And therefore, it can start up quicker, and it uses less memory, and it's more GraalVM friendly. So right now there is some competition, but I think it's very healthy competition. I'm very glad that this is there. It wouldn't be a good thing if the Spring framework would just be the dominant player, and there would be zero competition in this market, because then there is no drive there to do like drastic innovations that you can see with things like GraalVM and Micronaut and Quarkus, right? There's always continuously small improvements, but I think this is much more than that. This is really like a new paradigm almost. And yeah, I think it's good that it's there, and there is room enough, I think, for all three of these frameworks to exist. I think personally, Quarkus is much more interesting for people with a traditional Java EE background, right? They use JAX-RS and all of those APIs, where I think Micronaut is much more interesting for people already used to the Spring ecosystem, because it's much closer in its philosophy and its approach to doing things to Spring than it is to the traditional Java EE. And I think you will see a lot of back and forth between the two, actually. So yeah, there's some competition there, but not in a bad way.
Well, hopefully that answered your question, Hamza. Maybe Joris, you could share some final tips or some final information with us before we move forward.
Yeah, so one thing I think that's interesting for people is also if you're using Spring, right, regardless of whether you're new or whether you're already doing it for a long time, what are the ways that you can actually keep track of what's happening? So some resources that I would recommend are things like the Spring.io website has their own blog. So if it comes to things like release announcements, that's definitely something to keep an eye out for. So that you can see what's happening. The quality, I think, of release documentation that is shipped with most of the Spring frameworks out there, like Boot, Cloud, etc., is very high. So that's something to keep an eye out for. Personally, I'm a big fan of Twitter. So simply by following some people in the ecosystem, you can easily keep up to date with the new developments that are happening. I'm not the type of person myself who tends to actually watch GitHub repositories. I don't have time for that. I like to get, like, say, the management summary after people are done putting in new features, because well, I have a busy job myself. But that's some things to consider. Obviously, there's trainings, right? Doing a little bit of promotion here for ourselves. But that's mostly, I would say, good if you are still learning the framework, right? If you are a beginner, or if you're on a project and you're just copy-pasting stuff that other people have set up, but you don't really know why it works that way or why you're doing the things you're doing, that's really when training is applicable. After that, there's probably a better way of doing it. But of course, here at Trifork, since we are Spring experts, we are also a company you could also always ask for help. There's probably going to be some contact details after this meetup, so feel free to reach out if you have any problems that you think that we could help out with. And otherwise, ping me on Twitter afterwards. For example, my Twitter handle is Kuipers, so that's the first letter of my first name and then my last name. Should be easy to find. And otherwise, I thank you very much for attending this AMA.